Hi, this is Jacob Nash with JNGL. Today it is Unit 1, Lesson 5, Midpoint and Endpoint Rules, and also Distance Rules. I didn't put that up there. This is the last standard for this unit. The last video that I'll make. I will put out a review for this for 3 and 4. I already did one for 1 and 2, so you can see that. Okay, so first of all, you might think, what the heck is this weird picture thing? Well, you might recognize who that is if you went to elementary school. And that's I think like Math Antics. I used to watch that sometimes when I was in elementary school. But I put that there because there's something you have to remember that's important for this, what's it called? This video, yeah. And so, I'm going to just, go on this video right here. And, it's, Math Antics. And it's a little bit about what you need to know. But I'm not going to play the whole video, so.
Hi, this is Rob. Welcome to Math Antics.
Okay.
In this video, we're going to...
Back here. This is just something you need to know.
You know why I pulled you over today?
Some law?
That's right,
a law.
This law to be exact.
Laws of exponents? I've never even heard of these.
How was I supposed to know? Well, you must have never heard of Math Antics. They're this really cool math video series. They have all sorts of basic math videos. And the host is really funny. Is this some sort of ad? Can I skip this?
Okay, that's it. Yeah, that's all I need to show you. But there's just like rules that you need to know for like this thing, because if you don't follow those rules, then you'll mess up. So with these rules, there's easy ways and hard ways. If you want to choose the easy ways, you have to remember these exponent rules. Well, not just exponents, but also with like the distributing the negatives and positives and stuff. All right, let's get on with this. So, hey, oh yay, I can drag it. I didn't know that. Okay, calculating distance between two endpoints on a segment. So endpoints, that's what that is just the two endpoints, and then you have the segment, and then the midpoint's what's in the middle. Okay, so there's two ways you can calculate the distance between two endpoints, because that's what you'll be asked to do sometimes. Method A is the distance formula. And unfortunately, you do have to remember these, so it's not that hard to remember. It's the square root of x1 minus x2 squared plus y1 minus y2 squared. So the other way that you can do it is Pythagorean theorem, and I'll show you that. So here's an example. So the practice is not really going to be on this, because I'm just going to show you how to do it. There's not really, it took such a long time to do this. I didn't really need to do that. All right, if you want to do this, so this is the x1. That doesn't really work, but that's the x1. That's the x2. This is the y1. That's the y2. So the first one is the x, the second one is the y. So, all right. So you first want to just plug in the things. So all of this will give you the distance between them. And that can be a square root of something if it doesn't go out even, or something like that. So 3, 1, and 2, 4. All right, so let's get on with this. So first, square root. And then you have 3. Then you have minus. We have 2, because that's the second x. And in these cases, I don't think there's really a reason that you need to know those things, but if it had been -2, you would have just put a plus there, because if there's two negatives, if it's minus negative something, you just make it a plus like that. But that didn't happen this time. Okay, and then squared plus y1 That's just 1 minus 4. And then we have squared. All right, good. So now we do the math. So first, don't square first. First, do what's in the parentheses, because you know the PEMDAS. I don't know if you were ever taught that way, but parentheses, exponents, multiplication, division, addition, subtraction. That's the way you do it. All right, and 3 minus 2, that's just 1. Good. And then you have squared. Then you have 1 minus 4. That is negative 3 squared. Now, here's the case when you need to know your exponent rules. So exponent rules is that you have to know that when there's a negative in the square, if you square something that's negative and there's parentheses, then you make it positive. So it's positive 9. If there was no parentheses there, then it would just be negative 9. But it's going to be 9 for this part. And then 1 squared is still just 1. And then you add those together, and it equals 10. But remember, I forgot to keep drawing this, but there's still the square root over it. And can that break down? Well, the square roots, when we're simplifying radicals, that goes back to the first video I made. That's 1, 4, and 9 are the only ones that it could possibly be, because those are less than 10, but they don't even go into it. So that's what it is. And if you needed to like round it, let's see, you could just do that. Okay, square root of 10 equals. Something must have gone wrong, sorry. Okay, just forget it. You know, you would know what to do. You know how to round. So that's just how we're going to do it for this. Square root of 10. Remember, if it gets close to 15 minutes and it just cuts me off, that means that I took too long and there will be a part B. So that I feel like that might happen this time. All right, B, Pythagorean theorem. That's the other way you can do it. This one is easier, but you might not always be able to do it if you don't have graph paper, or if the graph paper that you're given does not have enough spaces to do the numbers. So like if it had been like 7 or 8, it wouldn't work for this one because it only has 4. All right, so first of all, you have to plot the points. So that's 3, 1. That's where our first endpoint is. And then you have 2, 4. 1, 2, 3, 4. Okay. Oh, sorry, that would be right here, actually. Okay, then the next thing that you do is you connect the dots. Just like that. You can do it with a like ruler or straight edge or something, but I'm just drawing it. So then you put down another point that would make it a triangle. So you might remember that it's the a squared plus b squared equals c squared. So you could put the point here to make it a triangle, or you could put it here. It doesn't matter. It doesn't change it. So I'm just going to put it here. And then you connect the lines to make it a triangle. So then what you do is you count the spaces. So this is what we're trying to find. C, in this case, is the distance that we're trying to find. So we have 1, 2, 3. That side is 3. And just 1 right here. 1. All right. So then we go to our formula. And remember, these are interchangeable. You know, our commutative, sorry, that's not what it is. All right, and then so we can do 3 squared plus 1 squared, that would be our a and b, equals c squared, because that's the variable we're trying to find. We don't know it. And so then we have 9 plus 1 equals c squared, and then that's 10, you add it together, then you take the square root of that, and you still get square root of 10. And notice those are the same numbers that are popping up right there. Good. That's what it is. Next slide. Okay, I clicked on it. Okay. Now, here comes the vocab that you know. All right. Simple, if you already know what a bisector is, because I already told you what an angle bisector is. And bi meaning to separate stuff into two, and section, that means that. You sometimes just have to use the prefixes and suffixes or whatever. All right, segment bisector. It segments or bisects to just a part of the segment. And remember, those lines mean that whatever the point is that it's there is the midpoint. So it could be just one line or two, but that's what it means. And M is midpoint. So that's what that is. That's all that is. It's just a line that will separate the two parts of the segment, and it intersects this segment at the midpoint. And then perpendicular bisector, and it forms the right angles, and it perpendicular, or that would have came out wrong. I don't really know how to say this. It just intersects with it and makes it perpendicular, and it does that at the midpoint. All right, midpoint formula. This is the one where there's only one way you can do it, really, at least that I know of. So if you know a different way, just do that. All right, so this is the formula that you have to know: x1 plus x2 divided by 2, comma, y1 plus y2 over 2, all in parentheses. So there's this comma because doing this together is what will give you the coordinates of your midpoint. So remember, the midpoint's what's in the middle. And so we plug this in. X1 is 8, because we're using these right here. And then we have let's see, x2. Okay, here's where you have to know your signs. So it's -6. So if we have a plus or minus, that x is out and makes it a minus. So minus. And then over 2, comma, and then y1 is 9. And then you have the thing again with the plus -3. So you just make it the minus. And then over 2. All in parentheses. Good. And 8 minus 6 is 2. 2 over 2 is 1. And then 9 minus 3 is 6. 6 over 2 is 3. These are the coordinates of this midpoint that we're talking about right here. If you hear something that's loud, that's just because I have a lot of family members, and I'm just doing this at my house. So that's what it is. All right, last thing is find the endpoint methods. There's 3 methods. I am actually going to cut off the video myself. You will see the midpoint endpoint methods in part lesson 5, part B. Just look at that. So, thank you for watching this part.